Well, the first important thing to recognise about matrix multiplication is that you don't necessarily do it to matrices of the same size. There are quite precise rules about when matrices can be multiplied, and they are to do with the shape and size of the two matrices. This pair can be multiplied, and the reason for that is that we have a 2 by 3 matrix, 2 rows and 3 columns, and a 3 by 1 matrix. The number of columns of the first matrix, 3, is the same as the number of rows of the second matrix, 3. And that's the first requirement. For multiplying two matrices, the number of columns of the first must be the same as the number of rows of the second. But look at the resulting matrix. It doesn't have the same shape as either of the first two. Well, if you look again, the first matrix has 2 rows, and the second matrix has 1 column. 2 rows, 1 column. The resulting matrix has 2 rows and 1 column. So that's how we're going to multiply. The column of the first must be the number of rows of the second, and the resulting matrix has the number of rows of the first and columns of the second. Seems pretty complicated.
It does, but fortunately there's a nice simple way of working out whether matrices can be multiplied and what the shape of the answer is. I can tell, without ever seeing them, that I can multiply a 50 by 100 matrix with a 100 by 1000 matrix. Now you see, the multiplication is possible because these two numbers are the same. And if I ignore the central part of this, I can see that the answer has to be a 50 by 1000 matrix. And I can do all of that without even knowing what the matrices in question are.
But of course we haven't yet told you actually how to multiply the matrices, even though you know that you can. Now I'll work entry by entry, and I'll start with this one up here. This is in the first row and first column, and we get it by multiplying the first row of the first matrix by the first, in this case the only column of the second matrix. Now the row and column have the same number of elements in it, and we multiply the 2 by the 7, then the 7 by the 1, and then the 1 by the 1. 2 7's 14, plus 7 plus 1 gives 22. And what about this second position here? This is the second row, first column. So we multiply second row by the column. 3 times 7, followed by the 2 times the 1, followed by 0 times the 1. 21 plus 2, giving us, as an answer, 23. The matrix, the column vector, 22, 23. Now that tip that Francesca gave you for knowing when matrices can be multiplied and what shape the answer is, well, it's so useful, I'm going to revisit it. Here, we multiplied this first matrix, which is 2 rows and 3 columns. That's a 2 by 3. And we multiplied this matrix, which has 3 rows and 1 column, a 3 by 1. And we obtained a 2 row by 1 column matrix. So basically what's happening is the number of columns of the first and rows of the second are the same. We can take that away, and our answer gives us the structure or the shape of the matrix in the result, a 2 by 1. And by the way, for this particular choice of matrices, this is the only